Welcome to Lesson 3, Graph and Determine Intercepts. Our objectives are to graph linear models for book value and depreciation and identify and interpret the intercepts. Now remember that our intercepts are where the line hits the y-axis, that would be our y-intercept, and then where the line hits the x-axis, such as right here, that would be our x-intercept. Notice this graph, the line does not hit the x-axis. Can you remember why that would be? Hopefully right now you're thinking, well, that's because this vehicle has a salvage value of 1,000, so we never really get to 0. We stop at 1,000. So in this case, there is no actual x-intercept as related to the problem. Now we know that in math, lines go on forever in both directions. So mathematically, this line does have an x-intercept, but contextually related to this scenario, the line would not have an x-intercept. If we look at the second graph over here, we do have a y-intercept and we do have an x-intercept. And that's because we have a starting book value and then the book value depreciates all the way to 0 here. Okay, let's continue on and look at some additional examples. So here we have straight line depreciation. You can tell because our line is straight, it's not curved. We decrease by a set amount each year. So let's think about our x-intercept right here. What is the value of this x-intercept? Well, typically x-intercepts we can think of as always some number, comma 0. And it's always going to be comma 0 because anywhere along the x-axis, y is 0. So for example, in this situation, where this dot is, it's almost 6, but it's not quite 6. So I would say that perhaps our x-intercept is somewhere around maybe 5.8 years. So the way we write our intercepts is always as a coordinate, is always as a pair of x and y coordinates. Now if we look at our y-intercept here, right, our y-intercept is always written as 0, comma, y, whatever the y is. And that's because anywhere along this y-axis, x is always going to be 0. So in this situation here, our y-intercept is going to be 0, 10,000. Okay, now if we look at this graph here, we do have a y-intercept, and it looks like it's about 0, 75,000. But do we have an x-intercept in this graph? And if you'll notice, we don't. It looks like instead we have a salvage value of about 10,000 and a useful life of 14. In this first graph, our useful life was 5.8 years. So we depreciated the entire book value down to 0 in 5.8 years. In this graph, we are depreciating this $75,000 vehicle only down to 10,000. Now if we were to make an equation though for this line, we would have to assume that it goes on forever. Okay, let's try our first example. The straight line depreciation equation for a car can be modeled by this equation. What we want to do is graph the equation, identify, and interpret the intercepts. Remember that when we graph these equations, the first thing we graph is the starting point, the original cost, right? The book value before any depreciation has been taken. So we would want to graph this here on the y-axis, which means we need to label the y-axis with some sort of interval that will get us to around 26,800. We also need to label the x-axis for time. And remember that time is in years. We depreciate our automobiles over a year at a time. So we would want to label our time just in years. So we would maybe label it as 1, 2, 3, and I'll continue to label it. Now I have my labels. So I go up to 20 here, and then I went by 2,000s here, all the way up to 30,000. I don't need to go above that because my original cost is 26,800. So if we go ahead and we mark that, that's going to be just above the 26,000 right about here. Well, if you're familiar with graphing a line, we could look at the slope and we could drop down 2,400, go over 1 year and make another point. We could drop down another 2,400 over 1 year and make another point. But really, what we're mostly interested in are the intercepts. So what I want to do is find, I know my y-intercept now, right? My y-intercept is going to be 0, 26,800. So let's go ahead and write that. Our y-intercept is 0, 26,800. So what I want now is my x-intercept. If I can graph that, then it's easy. I'll just connect the two dots. So my x-intercept is going to be some number and then a 0 for y. So how could I solve that? Well, what I can do is I can plug in the 0 for y, and then I can solve for x to get my x-intercept. In order to do that, I would need to move 26,800 to the other side of the equation. So I'll move that over now. After doing that, I would have negative 26,800 on the left. These are now gone, they've zeroed out, and I am left with a negative 2,400x. My final step then would be to divide both sides by negative 2,400. These cancel out, and my x-intercept is going to be divided by 2,400, 11.17. And that is my x-intercept. So again, we're going to have to do a rough estimate because we don't have 11.17 on our graph, but we can get very close. That's going to be just right about here. Once we have that, it's easy to graph the line. And then we'll go ahead and write 11. There it is, 11.17 for our x-intercept. So we have graphed the equation, we have identified the intercepts, but we have not interpreted them yet. So let's interpret them. Well, our first intercept here represents our original cost. That's what that y-intercept represents. We paid $26,800 at year 0 before we depreciated it at all. Then our x-intercept represents the total useful life of 11.17 years. And this means that our asset will be worth 0 after 11.17 years. Now we've interpreted our intercepts. Let's try another example. Example 2. The straight line depreciation equation for a car can be modeled by the equation 3y plus 2,400x equals 12,000. Now for this equation, we don't know what our y-intercept is because it's not in y equals mx plus b form. We could rewrite it in y equals mx plus b form, but remember, all we really care about are the x and y intercepts. Those are the most important parts of the graph for now. So let's go ahead and find the x-intercept. To find the x-intercept, remember, it looks something like this. We have an x value, and then we plug in a 0 for y. If we plug in a 0 here, we get 3 times 0, which is 0, and we're left with the equation 2,400x equals 12,000. To solve that, we would divide both sides by 2,400. This becomes just x, and 1,200 divided by 2,400 gives us 5, and that represents 5 years. That tells us a lot about the time. That means it has a useful life of 5 years. So if I'm making my scale, I could actually spread this scale out a little bit because I only need to go to 5 years. Okay, let's think about our y-intercept now. Our y-intercept is going to be 0, comma y. That means we're always going to have a 0 for x. So if we take our equation and we plug in a 0 for x here, well, 2,400 times 0 is 0. So that part of our equation is gone. And we are just left with 3y equals 12,000. To solve for y here, we just need to divide by 3. When we do that, we are left with just one y, and y is equal to $4,000. So that tells us a lot about our y-intercept too. That is our initial cost, and we only need to go up to $4,000. So for this equation, we could go by 500s, and we could say, or for the scale, we could call that 1,000, 1,500, 2,000, and so on up to 4,000. Now I probably could have used smaller increments just because I don't go very high here either. But we'll go ahead and stick with what we have, and then we'll draw in our line. So we know our y-intercept is going to start here at 4,000, and it's going to go to 5 years. So now I have graphed this equation using my intercepts, and let's interpret them. Well, at year 0, we paid $4,000 for our vehicle. That's the initial purchase price. Then, down here, at year 5, my vehicle has been fully depreciated, so it has a useful life of 5, and it's fully depreciated down to 0 years. Let's try a third example. Example 3. The straight line depreciation equation for a car with a salvage value of 2,000 can be modeled by this equation. We want to graph the equation, identify and interpret the intercepts and or endpoints. Notice that I'm using endpoints now because we have a salvage value. So think about this. Will we ever have a X intercept in this problem? Hopefully you are saying no, because we're never going to get to 0. So let's go ahead and graph this equation though. Well, we know our y-intercept is going to be 16,500. This is written in y equals mx plus b form. So if here's 16, here's 16,500 right here. And then we have a slope of negative 2,900. Now we could do one of two things. We could go ahead and graph the x-intercept because mathematically this equation does have an x-intercept. And then we could erase in order to make sure that we have a salvage value of 2,000. Or we could take the 2,000 and plug it in here for y. Because remember that y is our book value. And then we could solve for x to find our endpoint. So let's go ahead and do that so that we don't have to erase. So what I'm going to do is I'm going to put my salvage value here, 2,000, in for y, because that's as far down as I want to go. We're not going to depreciate this vehicle any lower than $2,000. So here's my equation. Let's go ahead and solve for x. First thing is we need to subtract 16,500 from both sides. When we do that, this cancels out, and we're left with negative 2,900x on the right. And on the left, we get negative 14,500. Final step is just divide by 2,900. These cancel out, and we can determine how long it's going to take to get to the salvage value if we divide 14,500 divided by 2,900, and that would be 5 years. And I know that negative divided by negative is a positive. Okay. We are ready to graph our endpoint. So let's go ahead and write our point so that we know what we're graphing. So the first point we graphed was our y-intercept, and that point was at 0, 16,500. Let's graph our other endpoint. We know that at 5 years, we are going to have a salvage value of $2,000. So that's our endpoint. Here's 5 years, and here is $2,000. So all I have to do is connect those points together, and now I have graphed this equation. All right, great. We have one more example to complete. Example 4. The value of a certain vehicle had a book value of $7,560 at the end of year 3 and a book value of $5,040 at the end of year 5. We want to write an equation to model this situation. We want to calculate the slope, graph, identify, and interpret the intercepts. So we want to do everything. Well, the first thing is to write the equation. We can write the equation of this if we have points. And if you'll notice up here in our example, we do have points. We know that it has a book value of $75.60 at the end of year 3. So let's go ahead and make that one of our points. So at 3, our value is $75.60. We have another point because at the end of year 5, our book value is $5,040. So we do have 2 points. And if you remember, whenever you have 2 points, you can find the slope of a line. Just to refresh your memory, the slope of a line is going to be the change in y over the change in x. In other words, y2 minus y1 divided by x2 minus x1. The change in y divided by the change in x. Any of these can be x1, y1, as long as we are consistent. We keep the 1's together and we keep the 2's together. Let's go ahead and calculate our slope. So I'll go ahead and call these x2, y2, and these x1, y1. So my slope is going to be 75.60 minus 50.40. That's the change in my y's, divided by 3 minus 5, change in x's. Doing this on the calculator, I always do my numerator first, and I get 2520. Divide that by 3 minus 5, which is negative 2. So in here I'm just going to divide by 2. I'm not going to worry about the negatives because I know the answer should be negative. And I get an answer of negative 1260. All right, that's my slope. Now think about this. What does that slope mean? That slope, hopefully you're thinking, that slope is our depreciation per year. That is how much we are reducing our book value per year. That's what our slope is. So if I were to write my equation now, I have this. Y equals negative 1260x plus b. I still need b. I need my original cost. How can I find my original cost? Well, I have 2 sets of points here that each have an x and a y, and I have an x and a y in my equation. So I can pick any one of these points, plug them in for x and y, and solve for b. I'm going to go ahead and plug in the 5 and the 50/40. Okay, I've plugged it in, and when I use my calculator to multiply, I get negative 6,300 here plus b. Now I just need to add 6,300 to both sides in order to figure out what my initial cost is, what my y-intercept is. Okay, and when I do that, I get an original cost of $11,340. So what I'm going to do is write my equation down here. So my equation is y equals negative 1260x plus 11,340. Now I know what my y-intercept is. It's 11,340. And I've gone by, these are all in thousands. So I've got 65.7, 75, 8 here, 85, 9, 95, 10. And so I'm going to need to change my scale because I need to have a y-intercept of 11,340. Here's my equation, and I've went ahead and plotted my y-intercept. I've changed my scale so that it can fit. Here is approximately 11,340. I have 2 other points that I can plot on here if I want, but I'm going to go ahead and find the x-intercept just so that my equation or my line is precise, and then I can interpret my intercepts better. So remember how to do that. What I need to do is plug in a 0 for y and solve. So when I solve for x, that will tell me what my x-intercept is. Solving for x, I get 9. So I know then that I have a x-intercept of 9. I can plot that point. I can now draw my line. And I have graphed my equation. Let's go ahead and interpret our intercepts. So here, this is saying that at year 0, we have a book value of 11,340, which means that's our purchase price. Down here, after 9 years, the car is no longer worth anything. We have depreciated it down to 0. Now let's think about our slope. Our slope is a negative 1260. This is our depreciation. This means we've depreciated our car by $1,260 every year until we got down to 0 at the end of year 9. And this concludes our lesson 3 on graph and determine intercepts. At this point, you should be able to graph linear models from y equals mx plus b or from standard form. And you should also be able to identify and interpret the intercepts.